Alright guys, so we're going to go ahead and get into some 3D figures. So this is going to be a pretty short section. We just have 4 sections to get through, and then we'll have a couple extra days of doing some surface area. But this first section is going to be very definition heavy, so be careful with that. Okay, so what we're going to do is we're going to go through this tonight. I'm going to let you guys get all these definitions down. We're going to review it tomorrow in class, and then we're going to do an activity. We will not do our homework on this until Wednesday, the following day. Okay, so the first thing I want you to get down are that solids are going to be 3D figures, and they can be made up of flat or curved surfaces. Each flat surface is called a face. The edge is the segment, that is the intersection. So here are your 2 faces right here, and here's your edge. And then your vertex is going to be the point that is the intersection of 3 or more faces. Okay, so vertex is going to be something familiar. Okay, edge is segment, guys, so you're going to write it as a segment, so watch out for that. So let's go through these different terms. My recommendation is you take some time and you actually do these drawings so that you guys can wrap your brain around what we're talking about, okay? Again, we're going to take some time to go through them tomorrow as well. I'm going to start with cylinder. A cylinder is formed by 2 parallel congruent circular bases, okay? These are your bases. Now your bases are going to be 2 congruent parallel faces. So this is a face and this is a face. They're parallel and they're congruent, so they're going to be called bases. Okay? I would use these to reference my shapes. We'll say that again in a few minutes. So it's made by those and a curved surface that connects their bases. This is your soup can right here. So here's there's no faces here, you just have a curved surface that wraps around those. You also have a cone. A cone is formed by a circular base, 1 circular base, and notice it has a vertex. So this is your ice cream cone. The curved surface connects the 2. So these are going to be familiar. Let's get into a prism. A prism is formed by 2 parallel, congruent polygonal faces. So these 2 shapes right here do not have to be triangles. They can be other shapes, as we'll see in a few minutes. So 2 congruent faces, they're called bases. The faces, the sides, are going to be parallelograms. That's what you're looking for to identify a prism. And then we have a pyramid. A pyramid is formed by a polygonal base, 1 base, and then a vertex. So you guys can think about the Egyptian pyramids to reference that. So this is the one I think we have to be careful with, okay? And then you have your triangular faces that needed a vertex. So let's extend this. I'm going to come back and talk about a cube in just a minute. Let's go through our prisms. So you guys, here, this is a prism. It fits my definition. I have 2 congruent triangular bases. They're parallel. I have parallelogram faces, so this is a triangular prism. My rectangular prism, here I have 2 congruent bases, but they're rectangles. Your pentagonal prism, your bases are pentagons. Notice my faces are still parallelograms. And then your hexagonal prism, your bases are hexagons, and again, my faces are still parallelograms. Okay? You can also have a square prism, as we're going to see in just a second. So a triangular pyramid, guys, notice all my sides are made up of triangles now, and my 1 base is a triangle. My 1 base is a rectangle. Again, the sides are triangles. My 1 base is a pentagon. My sides are triangles. My 1 base is a hexagon. My sides are triangles. Okay, so just be careful with these 2. And then, for these 2 concepts. Your cube is a prism with 6 square faces. Okay, so the cube has 6 square faces, and all those faces are congruent faces. Alright, we're going to go through, and there's something called Euler's formula. You say Euler, not Euler. It's not Ferris Bueller's Day Off. And it gives us a relationship between the faces, vertices, and edges. So this is basically your formula here. We'll have a couple quick little problems that we'll do as a side along with our homework. So if I have an example here, guys, I know that the faces plus the vertices equal the edges plus 2. Okay? So I want to find the faces. Faces plus vertices for this particular problem equal edges plus 2. So faces plus 9 equals 17, subtract that 9 over, and the number of faces you're going to have is going to be 8. So quick and easy. second and go through and classify these. This is where it can get a little bit funky, so just be careful with that. Okay? This can be a little bit tedious if you have lots of names, so watch out for a couple things that I'm going to warn you about. So for this, guys, I know this is going to be a pyramid, and then the base is a rectangle, so I know this is going to be a rectangular pyramid. I want to go ahead and I want to identify what it tells me to. So my vertices, B, A, C, D, and E. And then my edges, this is where you have to be careful. Your edges are segments, guys. Alright? So AB, segment AB, segment BC, I'll be looking for this on your test, segment CD, segment AD, segment ED, segment BC, and segment ED. Okay, so these are all our segments. And then the base is going to be named rectangle ABCD. Or whatever order you want to go, as long as you go consecutive. You can say BCA, for example. So let's do a cylinder just so we can make sure that we're clear on how some different things can work. So this is just a cylinder, and there's nothing crazy about the cylinder. A cylinder is just a cylinder. And for my vertices, I have none. For my edges, I have none. And that's okay, because I just have a curved surface. And for my base, I have circle P, and I have circle Q, and that's how we'll name our bases. So now, guys, we're going to get into what a net is. And we're going to take a second, and we're going to, in our mind, fold these up to see what shape they make. Tomorrow, we're going to fold these up physically. That's going to be the activity that we're going to do. So a net is basically a diagram of the surface of a 3D figure. It can be folded to form the 3D figure. Okay, so it can be folded to form a solid. So to identify it, look at the number of faces and the shape of each. The number of faces and the shape of each face. Alright? So let's describe it. So for this one, I have two congruent triangular bases. And then the faces are parallelograms. So I know it's going to be a pyramid, and because of the fact, a prism, and because of the fact that the bases are triangles, this is going to be a triangular prism. Okay, that is your full credit answer for your test. For this one, I have triangular faces, and I have one square base. So this is going to be a square pyramid. And there's your full credit answer. Why don't you guys just take a second and jot down these two. Faces are triangles, the base is a triangle, so this is going to be a triangle pyramid. Two circular bases, curve this guy around, so here's your cylinder. Alright, so this is going to be the last thing we're going to do, guys. This takes a little more visualization as well. Okay? A cross section is going to be your intersection of a 3D figure and a plane. So I just took my piece of cheese and I sliced it through my pyramid. I took my piece of cheese and I sliced it through my cylinder. Okay? So the cross section is going to be this guy right here. And that should probably be a familiar term for you. So the shape of the cross section, all we're going to write is a triangle. These are pretty straightforward. A couple are a little bit funky, so just be careful with that. Here's your cross section. The intersection is going to be a circle. Alright, why don't you guys pause the tape and take a second to jot down these. So here's your cross section right here, guys. And it's going to be the shape of a hexagon. 1, 2, 3, 4, 5, 6. Here's your cross section right here. And it's going to be the shape of a triangle. Okay, so just kind of wrap our mind around some of these and get used to our terms. This is what we'll do in a few days. Like I said, tomorrow we'll do our activity. So come in with your notes prepared tomorrow so we can go over them.